First, the orbits of the planets. Earlier in the 17th century, Kepler had discovered 3 laws of planetary motion that gave the correct mathematical description of the orbits. Newton was able to give a rigorous proof that Kepler's 3 laws describing planetary motion follow from his 1 law of universal gravitation. In other words, Newton began with Kepler's laws as the data for his induction of his universal law of gravity. Okay, number 2, the story of Newton and the apple that most of you have probably heard. Newton proved that the same force, the gravitational attraction of the Earth, explains both the moon's orbit and the rate that bodies fall to the ground here on the surface of the Earth. Okay, number 3, the ocean tides. Newton showed that the tides are due to the gravitational attraction of the moon and the sun. He was able to explain all the basic characteristics of the tides. Why high tide occurs twice a day, why tides are higher in the new and full moon than during half moon, why they are higher in the winter than in the summer, etc. Now, prior to Newton, the tides were a complete mystery. Kepler had hypothesized that the moon caused them, but Galileo had dismissed it as another of Kepler's crazy ideas. As some of you know, Kepler was a Pythagorean mystic, and it was sometimes difficult to distinguish between his good ideas and his crazy ideas. Number 4, Newton was able to explain the shape of the Earth. Newton realized that the gravitational force by itself would cause the Earth to be a sphere. If the only force acting on the Earth's mass was an attraction toward the center, the mass would arrange itself in such a way so that it was as close to the center as possible, which would make a sphere. But Newton realized that the centripetal force due to the Earth's rotation would cause it to bulge out at the equator and flatten at the poles. This is just the same effect that causes the clothes in your washing machine to go to the edges of the tub during spin cycle, right? Well, that's what happens to the Earth, pushing the mass out around the equator, causing the equatorial bulge. Now, Newton calculated the precise amount of the equatorial bulge. 50 years later, surveys proved him right. Number 5. Newton explained what is called the precession of the Earth's spin axis. Now, the Earth's axis of rotation is tilted with respect to the plane of its orbit around the sun. This is what accounts for the seasons. For instance, the northern hemisphere is tilted toward the sun now, which is why it's summertime here. Now, Newton figured out that this tilting of the Earth's axis with respect to the sun, coupled with the sun's gravitational attraction on the mass of the Earth's equatorial bulge, would cause the Earth's axis of rotation to cone around in a circle. Okay, what else? I've got one more for you. Number 6, the orbits of comets. Now, comets had always been regarded as mysterious and even of supernatural origin. Most people in the 17th century still believed they were signs of God's anger. Newton showed that the orbits of comets could be understood and predicted using universal laws that applied to all matter. In 1682, and this is just a few years before Newton published the Principia, there was a particularly visible comet. Starting from Newton's work, the astronomer Edmund Halley was able to predict the time of the comet's return 76 years later in early 1759. And it was a very dramatic event when the comet returned exactly on schedule. God's moods had gotten very predictable. Okay, now, what is the essential philosophic message implicit in the Principia? Now, you don't have to be a genius to get this. Newton beat you over the head with it. And I'll give you a hint. Ayn Rand called it the fundamental issue in philosophy. You said everything but what I'm looking for. The efficacy of reason. The Principia is a tour de force demonstration of the efficacy of reason. The greatest such demonstration in the history of science. Aside from the laws of physics that Newton proved, he proved the intelligibility of the universe, the unlimited power of reason to grasp the basic nature of reality. And the Principia hit the world like a bombshell. Even those who could not understand the mathematics understood its significance. Edmund Halley, who edited and published the first edition, expressed the basic message in an ode to Newton, which he included in the preface of the book. Now, I can only second Halley's reaction to Newton, and I can't say it any better than that. Halley gave Newton a much-deserved tribute, and he identified the main philosophic message of Newton's book, the potency of the human mind. Now, that message has a metaphysical corollary, that the universe is intelligible. And that brings me to my second philosophic point in connection with the Principia. Newton made possible a deeper, more profound understanding of the law of causality. The Greeks had understood causality, but in a qualitative way. Even Aristotle had said that his generalizations about the natural world were true, quote, always or for the most part, unquote. Now, the qualification for the most part was thought to be necessary for two reasons, one epistemological and the other metaphysical. Epistemologically, it expressed doubt about whether we could be certain of inductive generalizations about the physical world. Metaphysically, it expressed doubt about whether nature was 100% lawful. It left room for an element of contingency, accident, or chance. So even the Greeks did not grasp the full implications of causality. In the early 17th century, people were surprised when Kepler discovered that the planetary orbits could be described by mathematical laws. Kepler's explanation was that God loved mathematics and therefore designed the solar system accordingly. In other words, the fact that nature could be described mathematically was regarded as a miracle, not as a consequence of natural causality. But in fact, causality is the metaphysical basis for the mathematical description of nature. It's not a miracle that physical laws can be described mathematically. A mathematical law is simply an exact quantitative statement of our inductive generalization. Causality says that entities must act in accordance with their natures, not just most of the time, but all the time. And not just in a qualitative way, but down to every last detail, which we can describe quantitatively. Now, this is what Newton understood and demonstrated, that the universe is causal through and through, with no loopholes, no restrictions, no qualifications. Newton's discoveries made it possible to understand causality in its full glory. Okay, now there's a third crucial philosophic point to make in connection with Newton's physics. And it's a point that Newton made explicitly. He held as a matter of absolute principle that all scientific knowledge had to be based on observation. Now, to objectivists, that might not seem radical, but it was. Other 17th century scientists, Kepler, Descartes, even Galileo, did not accept that principle. Prior to Newton, it was very common for scientists to make arbitrary claims and then argue back and forth about them. New discoveries were often opposed because they conflicted with some arbitrary theory. For example, planetary orbits had to be circular, or colored light had to be a modification of pure white light. Now, Newton typically referred to arbitrary assertions as hypotheses. And explaining his terminology, Newton writes, quote, "The word hypotheses is here used by me to signify only such a proposition as is not a phenomenon, nor deduced from any phenomena, but assumed or supposed without experimental proof." and what Newton actually meant to say. I mean, the surrounding context shows that what Newton actually meant to say was without experimental evidence. Okay, now, Newton understood that accepting the arbitrary undercuts all knowledge, making it impossible to be certain of anything. Early in his career, he writes to a colleague, quote, "If anyone may offer conjectures about the truth of things from the mere possibility of hypotheses, I do not see by what stipulation anything certain can be determined in any science, since one or another set of hypotheses may always be devised which will appear to supply new difficulties. Hence I judge that one should abstain from contemplating hypotheses as from improper argumentation." Unquote. So Newton insists that the arbitrary be rejected without contemplation. Astounding. He's the only one in the history of, in recorded history that I know of prior to Ayn Rand that understood this point. Now, Newton laid down the following epistemological law to his colleagues. Any valid criticism of his physics must fall into one of two categories. Either it argues that his observations are insufficient to support his conclusions, or it cites further observations that contradict his conclusions. I quote again from Newton's correspondence. "The theory which I propounded was evinced to me, not by inferring 'tis thus because not otherwise. That is, not by deducing it only from a confutation of contrary suppositions, but by deriving it from observations positively and directly. And therefore I could wish all objections were suspended from hypotheses or from any grounds other than these two, of showing the insufficiency of observations to prove any part of my theory, or of producing other observations which directly contradict me, if any such may seem to occur." Unquote. Now, based on these comments and many others like them, I judge Newton to be the greatest epistemologist of his era, in addition to being the greatest physicist in history. Okay, to sum up, Newton's legacy transcends his incredible list of discoveries in physics, which I barely had time to touch on. He left us with a philosophic legacy as well, by bringing about a fundamental change in people's view of the universe and in the power of the human mind to understand it. The world of Newton is an integrated universe ruled throughout by the law of causality, a sunlit universe completely open to the human mind, provided that every step of our reasoning is guided by the evidence of our senses. And Newton had an interesting perspective on his own accomplishment. He realized how much he had done, but he also knew how much more remained to be discovered. His last major publication was a brilliant list of ideas and questions to be pursued by future researchers. Many of the ideas were confirmed by discoveries made long after his death. At the very end of his life, Newton offered the following description of himself. Quote, "I do not know what I may appear to the world, but to myself I seem to have been only a boy playing on the seashore, and diverting myself and now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Unquote. More than 200 years later, a jealous Albert Einstein began his preface to Newton's book on optics by exclaiming, "Fortunate Newton, happy childhood of science." Now, why was Einstein jealous? Well, in the intervening years, physics had lost sight of the great ocean of truth and had lost its innocence. And now we begin to look at how it happened.